Hello everyone. Today we're going to discuss about the formation and structures of polymers. Polymers. Polymers are large molecules made by bonding or chemically linking a series of building blocks. The word polymer comes from the Greek words for many parts. Each of those parts is scientists call a monomer, which in Greek means one part. Think of a polymer as a chain, with each of its links a monomer. Those monomers can be simple, just an atom or two or three, or they might be complicated ring-shaped structures containing a dozen or more atoms.
Major classifications of polymers based on origin. 1. Natural polymers. These are polymers that occur naturally in the environment. They are derived from living organisms such as plants, animals, and microorganisms. 2. Synthetic polymers. These are man-made polymers synthesized through chemical processes. They have a wide range of properties and applications. Classification based on the monomers present. Number 1. Homopolymer. A homopolymer is a type of polymer that consists of only one type of monomer repeated through its structure. This means that all the repeating units in a homopolymer are identical. Number 2. Heteropolymer. A heteropolymer is a polymer composed of two or more different kinds of monomers.
Copolymer. Different monomers are allowed to undergo copolymerization in order to form a polymer suitable for its intended application. Copolymers can be alternating copolymer, random copolymer, black polymer, and a graph copolymer. There are types of copolymers. First type is alternating copolymers. It is monomers alternate in a regular pattern along the chain.
Number 2. Random copolymers. Monomers are randomly distributed along the polymer chain. Number 3. Black copolymers. One type of monomer are linked to blocks of another type. They are formed when the block or small chains of one monomer or A is treated with a different monomer or B. Introduction of B is done at the time that polymerization of A is still going. Number 4. Graft copolymers. Chains of one type of monomer are grafted onto the backbone of another type. They are produced by the formation of a homopolymer of A, followed by introduction of B in the presence of high energy. This high energy creates a reactive site at random positions on the polymer of A at which B can polymerize.
Formation of polymers. Polymerization process. Polymers are formed through a process called polymerization, where small molecules called monomers chemically bond together to form long chains. There are two main types of polymerization. 1. Addition polymerization, chain growth. 2. Condensation polymerization, step growth. Addition polymerization, chain growth. In this type of polymerization, monomers add to each other without the loss of any small molecules. The reaction typically involves unsaturated monomers like ethylene and results in the formation of a polymer with repeating units identical to the monomers. Condensation polymerization, step growth. In condensation polymerization, each step of the reaction produces a small molecule like water or methanol as a byproduct. This method often involves monomers with two functional groups.
There are four types of structures of polymers. First is linear polymers. These polymers consist of long straight chains of repeating monomers. They can be highly flexible and can pack closely together, which often results in materials with high density and strength. The example is below. The second type of structures of polymers is branch polymers. Branch polymers have side chains of branching off from the main polymer backbone. The degree of branching can affect the polymer's density, melting point, and solubility. The example is below. The third type of structures of polymers is cross-linked polymers. In cross-linked polymers, the polymer chains are linked together by covalent bonds, forming a three-dimensional network. This structure makes them rigid and often insoluble in solvents. The example is below. The last type of structures of polymers is network polymers. Network polymers have a highly interconnected structure due to extensive cross-linking. This results in materials that are very strong, rigid, and often insoluble. The example is below.
Well, that's all for today. Thank you for listening, and we hope you learned a lot.